everyone, and welcome back for another deep dive. This time, we're going to be looking at knowledge graphs and graph neural networks.
Okay.
You've sent us a really interesting collection of sources on this.
Yeah.
We've got some academic articles, we've got blog posts, even some encyclopedia entries and stuff from LinkedIn and Amazon.
Wow.
Yeah, so it seems like you're really interested in this world where data isn't just rows and columns,
Right.
but like a web of connections and meaning.
It's a really fascinating shift, I think, this move away from just thinking about data points in isolation
Yeah.
towards understanding the relationships between them. And that's really what a knowledge graph is all about.
Okay, so it's like a map then.
Yeah, you could think of it that way.
Instead of streets and cities, we're talking about people and ideas and organizations all linked together.
Exactly.
A lot of our sources actually describe it that way.
Yeah.
I saw that in like the Sale blog and the Wikipedia article.
Yeah, think of it like a family tree.
Okay.
But instead of just showing lineage, it captures all sorts of relationships.
Okay.
So let's say we have a node for Jens Lehmann.
Oh, yeah. The Arsenal goalkeeper.
Exactly. So Jens Lehmann is our node. And then we have edges connecting him to other nodes like Arsenal with the relationship plays for, or Premier League with the relationship won.
So we're like taking all those random facts we know about Jens Lehmann and actually like organizing them
Yeah,
in a way that makes sense both to us as humans and to a computer.
exactly. And that's one of the reasons why knowledge graphs are becoming so popular.
I see.
It kind of bridges this gap between how we think about the world and how machines process information.
Our sources definitely highlighted that. Like the ACM article talked about how organizations are using knowledge graphs to like manage their knowledge better,
Yeah.
share it more effectively. And then that book, Knowledge Graphs, that you sent, the fact that it was published by MIT Press as part of their AI series,
Oh, wow.
that alone tells you that this is a pretty important field.
For sure. And they go into some really interesting applications of knowledge graphs too. Like things like predicting cyber attacks,
Wow.
personalizing product recommendations, even things like analyzing research on COVID-19.
Really?
Yeah, to accelerate breakthroughs.
Wow.
So it's not just theoretical anymore. Knowledge graphs are having a real impact.
Well, that's what I was going to say, is that YouTube video that you sent about data access,
Yeah.
it really kind of like hit home the struggles that people face with traditional databases and these data silos.
Right.
And I mean, they even questioned in the video, like, are knowledge graphs just toys?
Yeah.
Like, is this all hype or is this the real deal?
That's a fair question.
Yeah.
And there's definitely some skepticism out there, but
Yeah.
I think the video makes a good case for knowledge graphs as a solution to this problem of data integration.
Yeah, it's like bringing all this information together in a way that makes sense and is actually useful.
Right.
So, okay, we've got these cool maps of knowledge, but how do we actually like build them? I mean, it can't be as simple as just drawing lines between things, right?
Yeah, it's definitely more complex than that, but that Sale blog post you sent does a pretty good job of explaining this concept called co-occurrence matrices.
Okay.
So imagine you're looking at a social network.
Okay.
You could look at how often people interact or appear together in photos,
Uh-huh.
and you could use that to kind of infer the strength of their relationship.
So like using data to kind of like uncover those hidden connections and reveal that underlying structure.
Exactly.
Okay.
And then you can layer in additional information from other sources.
Okay.
You know, the Knowledge Graphs book talks about using natural language processing to extract knowledge from unstructured text.
Oh, wow.
So you could analyze like news articles or research papers to add new entities and relationships to your knowledge graph.
So it's like teaching a machine to read and understand and then build this giant web of knowledge.
Exactly.
That's amazing.
And they can get really detailed too.
yeah.
That YouTube video gave a simplified example of a knowledge graph about humans, coffee, and sleep.
Oh, the classic coffee prevents sleep dilemma.
Right. Exactly.
Yeah, I can relate to that one for sure. But, okay, so we've got these really intricate graphs.
Yeah.
What do we actually do with them? Like, what's the point?
That's where things get even more interesting.
Okay.
Because now we move from just representing knowledge to actually using it to learn and make predictions.
Okay.
And that's where graph neural networks, or GNNs, come into play.
Okay, and I was hoping we could talk a little bit more about GNNs because that gentle introduction to Graph Neural Networks article that you sent
Yeah.
was a great starting point. But, like, how do they differ from the traditional machine learning stuff that we always hear about?
Right. So traditional machine learning algorithms often look at data points in isolation,
Okay.
but GNNs actually take advantage of the fact that data is interconnected, that entities have relationships with each other.
Okay.
So it's a very different way of approaching the problem.
So instead of just looking at each data point on its own, it's like looking at the whole neighborhood. The entire web of connections.
And they do this through a process called message passing.
Okay, message passing, what does that mean?
So imagine each node in the graph is having a conversation with its neighbors.
Uh-huh.
They're sharing information about themselves and what they know.
Okay.
And then based on these interactions, they update their own understanding.
Wow, so they're like learning from each other.
Yeah, you can think of it that way.
Constantly refining their knowledge based on the information that they're receiving.
It's like this constant flow of information rippling through the network.
That's a really cool way to visualize it.
Yeah, and this process of message passing is really what allows GNNs to capture the complexity of these relationships in a way that traditional algorithms can't.
So I'm starting to see why this is such a big deal.
Yeah.
It's like we're moving beyond just crunching numbers to actually teaching machines to understand the world in a way that's more like how humans do it.
Yeah, I think that's a great way to put it.
Yeah.
It really is a big deal, I think.
Yeah.
It opens up so many possibilities. Yeah. And that GNN playground that you mentioned in that article,
Right.
that sounds like a really cool way to actually experiment with these networks and see how they learn.
Yeah, it's all about getting hands-on, right? It's not about memorizing formulas or anything.
Right.
It's like really understanding how these things work.
Exactly. And in this playground, you can actually tweak different parameters,
Okay.
like the number of layers in the network or the types of messages that are being passed.
Okay.
And you can actually see how those changes affect the GNN's performance.
So it's like you're not just passively observing,
Yeah.
you're actually participating in the learning process.
Right.
It's like being a scientist in a lab, but instead of beakers and chemicals, you're dealing with algorithms and data.
That's a great analogy.
And speaking of playing, remember that paper about knowledge graph embeddings?
Yeah.
It's like we're taking this complex web of information and turning it into something that machines can actually understand.
Right, like compressing all of that knowledge into a form that's more digestible for the GNN.
So these embeddings, they capture the essence of each entity, right?
Yeah.
And it's relationships, making it easier for the GNN to actually learn from them.
Exactly. And this opens up some really interesting applications.
Okay, like what?
So one example is knowledge graph completion.
Okay.
There was a paper about that
Uh-huh.
where they talked about using GNNs to predict missing links in the knowledge graph.
So like if we know that Jens Lehmann played for Arsenal,
Yeah.
but we're missing information about him playing for AC Milan, the GNN could actually predict that connection
Right.
just based on the other information that it already has.
Yeah, it's like filling in the gaps in our knowledge, using these networks to uncover hidden connections.
Okay, that's really cool. Do you have any like real world examples of how knowledge graphs and GNNs are actually being used?
Yeah, so there was a paper that talked about a deep learning approach to antibiotic discovery.
Okay.
And researchers used GNNs to analyze this massive data set of molecules and their properties. And the GNN was actually able to identify a new antibiotic
Wow.
that had been overlooked by traditional methods.
So we're talking about potentially developing new life-saving treatments.
Yeah.
That's incredible.
Yeah. And this approach isn't limited to drug discovery either.
Okay.
You know, knowledge graphs and GNNs are being applied to lots of different scientific challenges like materials science, climate modeling.
Right. It's like helping us make sense of these complex systems and uncover new insights that we couldn't have found using traditional methods.
Right.
It makes me think of that section in the Knowledge Graphs book where they talked about analyzing all of those papers on COVID-19.
Yeah.
It's like we can use AI to help us understand these global challenges.
Exactly. And I think this leads to a much broader point.
Okay.
We're not just talking about specific applications here.
Yeah.
We're talking about a fundamental shift in how we think about knowledge.
Okay, so how are they changing our perspective on knowledge then?
Well, traditionally, we've treated data as something static, something to be stored in databases.
Right.
But knowledge graphs and this idea of the semantic web envision a world where information is interconnected
Okay.
and constantly evolving.
So it's like moving from a library of books to like a living encyclopedia.
Exactly.
Where everything is linked together.
Yeah, and machines can play a much more active role in this world.
Uh-huh.
They can help us navigate this vast network of information,
Right.
discover new connections, and even generate new knowledge.
It's like we're giving the web a brain, like Tim Berners-Lee said.
That's right.
I remember reading that in one of the articles, the Link to Data article.
Yeah, and with knowledge graphs and GNNs, we're actually getting closer to that vision.
I see.
Moving from a web of documents to a web of data, a web of meaning,
That's a big statement.
It is, but it has the potential to change everything.
Yeah, and this whole idea of interconnectedness, it
Yeah.
seems like it has implications far beyond just technology.
It definitely does. I mean, think about how we learn, how we solve problems, how we make decisions.
Yeah.
It's all about making connections, seeing patterns.
Right, it's like in a mystery novel.
Yeah.
You're not just collecting clues,
No.
you're trying to figure out how they all fit together to tell the story.
Exactly. And that's essentially what we're doing with knowledge graphs and GNNs.
I see.
We're piecing together this more complete picture of the world by understanding how things are related.
So this graph-based approach, it's becoming important in a lot of different fields then.
Yeah, absolutely. From science and engineering to business and even the arts.
So it's not just about the technology itself.
Right.
It's about a fundamental shift in how we think about problems and how we understand the world.
Yeah, it's a new lens through which to view complexity.
Okay, so we've talked about all these amazing things that knowledge graphs and GNNs can do, but what are some of the challenges?
Well, one of the biggest challenges is just the sheer complexity of building these massive knowledge graphs. It requires sophisticated techniques for data integration,
Okay.
ensuring accuracy,
Uh-huh.
and dealing with the fact that information is constantly changing.
It's like a giant, constantly changing jigsaw puzzle.
Yeah, with pieces coming from all sorts of different sources.
Yeah, it sounds really messy.
It can be.
So how do we deal with that?
Well, that's why standardization is so important. And that RDF primer that you sent
Okay.
really emphasizes that. We need a standardized way to represent knowledge
Okay.
using technologies like RDF.
So it's like creating a common language for machines to communicate about knowledge.
Exactly.
Okay, I see. But even with standardization,
Yeah.
there's still the challenge of dealing with ambiguity, right?
Yeah.
Like in human language.
Human language is inherently ambiguous.
Yeah.
And natural language processing has come a long way.
Uh-huh.
But machines are still not perfect at understanding the nuances of human communication.
Like sarcasm.
Exactly.
Exactly.
Those are really tough for machines to get. So we still need human expertise
Oh,
to curate the data and ensure that the knowledge that's being represented is accurate and reliable.
so it's not about replacing human intelligence.
Right.
It's about this collaboration between humans and machines.
Exactly.
Using the strengths of both to build this more complete understanding of the world.
And this collaboration is actually leading to some really exciting advances.
Like what?
So one trend that's particularly interesting is this idea of integrating knowledge graphs with other technologies.
Okay.
So that paper, Knowledge Graphs Meet Multimodal Learning, explores how we can combine knowledge graphs with data from multiple sources,
Okay.
not just text,
Uh-huh.
but also things like images, videos, audio, sensor data.
So it's like instead of just reading about a historical event,
Yeah,
you could actually see footage of it,
right.
hear firsthand accounts, maybe even experience the environment through sensor data.
Yeah, it's like stepping into a time machine.
And this could revolutionize all sorts of fields, right?
Absolutely, like journalism, media analysis, even intelligence gathering.
It's like giving machines the ability to perceive the world in a much richer way.
Right,
It's not just about understanding words on a page anymore.
exactly.
It's about being able to see and hear and feel what's happening.
And this leads to another really important area of research,
Okay.
which is explainable AI or XAI.
Okay.
As GNNs become more complex,
Uh-huh.
it becomes more and more important that we understand how they're arriving at their predictions.
Okay.
We need to be able to trust the insights that they're providing.
Yeah. It's not enough to just get an answer from an AI.
Right.
We need to know why it gave us that answer. Like, what was the logic behind it?
Exactly, especially in fields like healthcare or finance, where the stakes are so high.
Right. Those are really important points.
Yeah. And thankfully, researchers are tackling this challenge head on.
Okay.
There were those papers, GN Explainer, and that other one about explainability methods for graph convolutional networks. They're developing techniques to make these GNNs more transparent so we can actually understand how they work.
So it's not just about building smarter machines.
Right.
It's about building machines that we can trust.
And that can explain their reasoning.
Right. So that we can make better decisions.
Exactly.
Okay. But this need for transparency,
Yeah.
it becomes even more important when you consider that knowledge itself is always changing, right?
That's right. The world is constantly changing, and our knowledge needs to keep up.
It's not like we can just build a knowledge graph once and be done with it.
Right. It needs to be constantly updated,
Okay.
incorporate new information, and revise existing knowledge as we learn more.
So how do we keep track of all those changes?
Well, that raises questions about version control and provenance.
Okay.
How do we track how a knowledge graph has evolved over time?
Mm-hmm.
How do we understand why it's changed?
Right.
How do we make sure we're not losing valuable information or introducing errors?
It's like keeping track of every edit to a Wikipedia page.
Yeah, but on a much larger scale.
Yeah, a much bigger problem.
Yeah, and with much higher stakes.
Yeah, for sure.
So researchers are exploring different approaches to this.
Okay.
Some are using blockchain technology to track changes.
Okay.
So that creates an immutable record of every modification.
Wow.
Others are developing sophisticated methods for knowledge provenance,
Okay.
which is like creating a lineage for every piece of information in the graph.
So it's like a digital audit trail for knowledge.
That's a great way to put it.
Yeah, so we can understand where it came from, how it's changed, and how trustworthy it is.
Exactly.
But even if we solve that problem,
Yeah.
we still have the issue of scale, right?
Right.
I mean, we've been talking about these massive knowledge graphs
Uh-huh.
with billions of entities and trillions of relationships.
It's a huge challenge.
Yeah, how do we actually make these things work?
Well, traditional graph algorithms and databases,
Okay.
they often struggle to handle data at this scale. So researchers are developing new techniques for distributed graph processing,
Okay.
using clusters of computers to basically parallelize the computations.
So it's like taking this huge task and breaking it down into smaller pieces.
Yeah.
That can be processed by multiple computers at the same time.
Exactly.
So we can solve problems that would be impossible for a single machine to handle.
That's right. And beyond just distributed processing,
Yeah.
people are also developing new data structures and algorithms that are specifically designed for knowledge graphs.
Okay.
Things like graph databases and graph query languages.
So it's like a whole new set of tools
Yeah.
for working with this interconnected view of knowledge.
Exactly. And this shift to graph-based approaches.
Yeah.
It's not just impacting how we build knowledge graphs. It's also changing how we design and develop AI systems in general.
Wow. So graph neural networks, they're not just a niche technology then. It's like
Yeah.
a fundamental shift in how we approach AI.
Just like we're finally starting to embrace the complexity of the world
Right.
and build machines that can do the same.
And this realization
Yeah.
that the world itself is this complex network. It's driving all these new applications for GNNs in all sorts of fields.
Exactly.
Yeah, it really feels like we're entering this new era of AI,
Yeah.
where it's not just about looking at individual data points anymore. It's
Yeah.
about understanding how everything is connected.
I agree. It's a really big shift.
It is. And you know, it's funny.
What's that?
We always talk about AI in terms of machines becoming more human-like.
Right.
But in this case, it's almost like we're the ones
Yeah.
who are learning to see the world more like machines do.
Yeah, in terms of networks and connections.
Exactly.
It's an interesting thought.
Yeah.
Maybe it's not about machines becoming more human or humans becoming more like machines,
Right.
but finding this common ground, a way to bridge the gap between our different ways of understanding the world.
And it seems like knowledge graphs and GNNs are a big part of that bridge.
Yeah, I think so.
They give us this framework for representing and thinking about this interconnectedness.
And this shift towards graph-based thinking,
Yeah.
this idea that relationships are just as important as the entities themselves,
Uh-huh.
it really challenges that traditional reductionist view of knowledge.
Right, like the idea that if we just break things down into small enough pieces,
Yeah.
we can understand the whole...
But you miss the big picture.
Yeah, you miss the forest for the trees.
Exactly.
You overlook all those connections that make the whole greater than the sum of its parts.
Right. And knowledge graphs and GNNs
Yeah.
offer a much more holistic perspective.
Yeah, and this interconnected view of knowledge.
Yeah.
It has implications for everything, right?
Yeah, I think so.
How we learn, how we solve problems, how we interact with the world.
It's not just about memorizing facts anymore.
Right.
It's about understanding how those facts are related.
And how they fit into this bigger picture.
Exactly.
So as we wrap up this deep dive
Yeah.
into the world of knowledge graphs and graph neural networks, what are some key takeaways for our listener?
Well, I think the most important thing to remember is that knowledge is not just a collection of isolated facts.
Right.
It's this network of interconnected entities and relationships.
Okay.
And knowledge graphs give us a really powerful way to represent and reason about that interconnectedness.
And then graph neural networks allow us to learn from those knowledge graphs
Right.
and make predictions about the world.
Yeah, they're already having a huge impact in so many different fields. And we're really just scratching the surface of what's possible.
It's really exciting to think about.
It is.
And I guess the last takeaway is that this is a journey of discovery,
Yeah.
both for us as humans and for the AI systems that we create.
As we explore this world of knowledge graphs and GNNs,
Yeah.
we're learning not just about the world around us, but also about the nature of knowledge itself.
That's a really profound thought.
Yeah. It is.
And I think it's a great place to end our deep dive.
Yeah, I agree.
We've covered a lot of ground today.
We have.
From the basics of knowledge graphs to these really mind-bending possibilities of GNNs.
Yeah, and I hope our listener has come away with a better understanding of these technologies
Me too.
and the potential that they hold for the future.
Absolutely. And for our listeners, if you want to learn more,
Yeah.
be sure to check out the show notes.
Okay.
We've got links to all of the sources that we talked about.
Right.
Happy deep diving, everyone.